Welcome to Microsoft Build 2017. Thank you for tuning into our session. Today, Romit and I are going to share with you how you as a developer can go about leveraging all the cloud data services to build your data-driven applications. Now, to start off, we're going to share with you some of these constant or common data processing requirements that we've been hearing from our customers. Now, and this really starts off with us as developers building an application. Well, after you build an application, you have the data stored in some data store. Now, as and when you want to make use of the data, right, in order to build or to inform you of feature decisions that you should go about in the next version of your applications, you might want to start processing the data or cooking the data in some ways. And sometimes you make use of ETL tools to land the data into a relational data store like a data warehouse. And the point there is for you to gain insights into how users are using your application, and then using that to make your next draft of your application much better. Now, and as we start evolving, you want to be able to have reports or dashboards to give you insights into how your application is doing at this point in time. And at the same time, you might also want to get real-time insights. Real-time insights into what are the kinds of failures from the API calls that you have, or what is the success rate. Right? And to do all of this, you might need different kinds of tools, right? From real-time processing engines to being able to do big data processing in big data store. And today, one of the increasing conversation that we've been hearing is really the fact that, well, I do not just want to build that application. I want to build the application that rocks. And more importantly, being able to leverage machine learning and AI, right? To get to a point where not only do I have a data-driven application, I have a really intelligent application that differentiates me from the many applications that's out there. Now, the next piece that we're going to share is, well, I have data sitting in some data store. And in order for me to build the intelligent application, how can I transform all this data that I have in some way or another into intelligent action, into an intelligent action that, right, your users can use in your application? Well, we look at two different models. One is really a really traditional way of doing data processing where you have data stored in some relational store, right? And you make use of tools like ETL, as we shared with you earlier, to be able to process this, to be able to enrich them, and finally being able to land them in some data store, right, that will power all your kinds of dashboard reports, right? And all this is geared towards helping you make that smart decision for your next draft of your application. But today, we're increasingly seeing data of different kinds of shapes and sizes. This could be data that gets stored in different kinds of store, whether it's relational, non-relational store. And more importantly, this data is coming in at a velocity of unprecedented scale. And therefore, you might want to make use of big data stores to store and enrich and process this data. But the point here is the same, right? Whether you're looking at a traditional data processing pattern, or whether you're looking at this new evolving data processing pattern, is to land the data somewhere, cook it, and then get this insight to you and your team for you to build the next killer application. Now, let us next look at the different kinds of components that we have been seeing so far, right, in common applications. Now, this could mean that, well, as you build your data-driven solution, you might need to think of ways of how you should go about ingesting the data into all these data stores that we're going to talk about later on in this session. And more importantly, how can you go about processing them, analyzing them so that you can act on this data? And the different kinds of varied data stores that's out there, you choose a data store depending on your evolving data processing need at that point in time. And last but not least, you really want to serve your data. You want to be able to consume this insight, right, and use them in intelligent ways. Now, next we look at ingestion patterns. Today, you see a lot of different kinds of ingestion patterns. And one of them could be real-time ingestion, where data is continuously arriving, right, at millions of events or messages per second. How can you deal with it? Or it could be near-time or near real-time ingestion pattern, where you have data that's received from web forms, you have telemetry data that gets logged somewhere, right? And you really want to be able to work with this kind of ingestion pattern. Now, the next tool is really one-time load, where you could have data sitting in some on-premises data store. It could be flat files that's on-premises, and you want to do a one-time migration of this data into your cloud data store so that your applications that you're building can leverage this data in your cloud data store. And the last piece is really a very interesting pattern that I've been seeing a lot is that while you could still be maintaining your on-premises systems, and on a nightly basis, you want to bring some of this data from your on-premises systems into your cloud data store and schedule this data movement. And the point there is then your application will get the latest and greatest of data and being able to make use of it.
Right.
Now the next piece is, well, now that we have looked at the ingestion and different ways of ingesting data, let's take a look at the different kinds of processing patterns. Right? Today, this is really simple. Right? You could either be doing real-time processing. You're able to deal with all this data that's continuously arriving at millions of events or messages per second. But more importantly, being able to do Windows queries on top of it, being able to trigger off alerts and notification when certain values or certain aggregate values in some time window exceeds your expectation or threshold. And a very common pattern that is there as well is batch processing. Right? You have all this data being ingested, raw data that first you might have, you know what kind of business questions that you want to ask, or raw data that you have ingested into a data lake. And you just want it to be there to have the confidence that later on, when you know what questions you want to ask, it is there and you are able to process it at scale.
Right.
Now, once we look at all this, we really want to get all these insights into the hands of the developer, into the hand of the stakeholders. And the point here is to help you build the next rev of your app or decide what you should be building or what you should not be building. And therefore, we look at different kind of data serving patterns, from being able to build dashboards and reports to having point-in-time ad hoc queries that you just want to ask specific questions just to gain the additional insight. And being also able to do interactive data access for you to be able to slice and dice and drill down to specific data points that will help you again make an informed decision. And the last piece is really the different kinds of data storage available, from hot stores to warm stores to cold stores to analytical store. And which store would you choose really depends on your requirements. And it also depends on what kind of insights that you hope to derive from it.
So Weong, one question for you there. What's the difference between these type of stores? So you mentioned we've got four, you said we've got hot store, we've got cold store. Mm-hmm. What's the basic difference? How do I, what's one good for, what's the other good for?
So for example, you have hot stores, and this is really stores that allows you to have quick access to the data that you want, right? And more importantly, being able to do lightweight interactive queries. But the consideration there is really the fact or a trade-off between what kind of latency you're expecting, right, versus the cost of storing the data, right? And therefore, if your data is not going to be accessed really frequently, you might choose to put them into a cold store, right? And if
or even a warm store.
In a warm store as well, that's right. Yeah,
great.
Now, and the last piece that I really want to cover before we hit into the solution patterns is the kinds of data stores that's out there. And today on Azure, you have all these kinds of stores available to you as managed services. This goes from data stores that allows you to keep your transient or staging data, to being able to do big data processing, right? To relational stores that we all are familiar and we love and we'll be using it to power all the applications that we're building, to non-relational stores as well. Today, we're increasingly seeing application patterns or solutions, right, that leverage non-relational store for storing JSON data, for storing graph data or time series data, right? And the key there is really the fact that what are the requirements? What are your requirements when developing your data-driven application, right? It could be consideration for the volume of data that you need to store, the velocity in which data is arriving, or whether you have a real-time batch processing need, right? To simply the read-write latency that you tolerate, right? All the types of data to be stored, right? And next, we're just going to share with you, right, what are the different kinds of solution patterns, and Romy is going to share with you some of this pattern that's been seen when working with customers.
Great. Well, thank you, Weong. I think that was an excellent introduction. I think the point that again I want to reiterate that Weong laid down, which is you choose your data store based on your requirements, right? Based on your velocity requirements, based on your throughput requirements, based on your latency requirements. And there's certain data stores out there in the world that are good for, say, hot data storage or for quick access, while there's some data stores in this world that are good for warm data stores and that are cheap to store but are not good when it comes to throughput or when it comes to latency. But there's some that are really good at that. And so that being said, let's dive into some of the solution patterns, right? And so let's take a point in action, or let's take an example in action, I believe, which is of, let's say I am an app developer and I built a travel website, a website where my users can come in and buy airplane tickets and hotel rooms. And so I build an application, and of course, in order for me to store the data or my transactions, which is, hey, when somebody comes in, buys an airplane ticket, I want to store that in a database. I'm going to go ahead and create a database for that, right? And in this case, because I have high throughput requirements, which means as soon as I hit the database, I need my data stored. I don't want to wait on, I don't want a slow data store there, so I'm going to go ahead and use a hot data store, an OLTP data store. And now once a user comes in, buys an airplane ticket, and now wants to go and check what his recent orders were or recent airplane purchases were, I need to be able to pull that exact data within my application again. And so in that case, I need that application to read again from that database. And so as you can see, my database there has a requirement of not only high throughput reads, but also high throughput writes, right? And so, I'm sorry, writes and reads. And so we need to be able to handle both using that database. And so in that case, a transactional store, an OLTP, if you're from the data world, or a hot store, as we call it these days, can be used to try and get that done. Now, another aspect to that is, I want to try and archive all this data. So down the road, if I want to try and make my application a little bit more intelligent, I can use that data. I don't know how I want to use that data today, but I know I might want to use it later. So I can go ahead and use a cold store to try and store my data. Again, cold store is cheaper to use, so I can easily store my data for a longer term, but keep the hot data, which the most current data, so I can even pull it within my application. It's the most basic pattern we see with any developer out there that's trying to build an application, right? Now, what happens when you're trying to build intelligence into your application, when you're trying to process your data in real time, so you can try and make it a little bit more interesting, right? But before we go into that, right, I want to also point out that, hey, we've got, we talked about the components. We talked about the components of any data-driven application, which is ingest, storage, processing, and serving. And so out of this, because we're not doing any processing on our data, we have our three components that are served here. And again, it's not that every single component needs to be used in every application, but almost 80-85%, I think we see the same, a similar pattern being carried through. The next type of solution pattern is, okay, let's, now that my website's growing, I want to try and do some real-time processing. I want to try and get some more alerts of when ticket prices fall up and down, so I can, give some more, a better customer experience to my users that are coming onto my website. So in this case, I need to process my data as it comes in. Ticket purchases, I might have other information coming in from other travel websites that are selling these tickets. And so in this case, I need to have a messaging queue in the architecture. And so if you look at the architecture again, we need to have a messaging queue that can go in and hold our messages. And the reason why we need to have a messaging queue is because once we start getting over a certain threshold for data, your hot database, your transactional databases start throttling you out to say, okay, well, once you start storing more than 1,000 messages a second, the throughput starts phasing out or fading out. And at that point, what happens is you're going to start to see some latency in your application. And so it's always a good practice to use a messaging queue that can ingest all the data. It's like a data catcher that just says, come on, throw data at me, I'll catch it, and then I'll pass it back on to whoever needs access to it. And once we have our messaging queue, we can now start putting in real-time ingestion real-time processing engine, so we can process our data in real time, and without much latency, pick up the data from the queue, process the data, pass it on to whoever needs to get access to it next. And so in our architecture, again, we can see that once our data is being processed in real time, we can either choose to send it to something like a dashboard or a report, so my C-level executives can see what's happening on our website in real time, or I can send my data to a hot store, so my application can pull that data and start showing travel alerts and trend analysis in real time as data becomes available. Finally, I can even store all of this near real-time process data into my warm store. And what that would enable me to do is, at a later time, I can actually run some more meaningful analytics on top of my data if I want to make my application truly, truly intelligent. And that leads us into solution pattern number 3. But before we do go into that, I did miss a very small point, which is, yes, again, it fits into our 4 buckets of ingest, process, storage, and serve. right? And so you're going to see this time and again, which is it fits into these 4 buckets, right? And so when you're trying to design your application and you're trying to design your data application or data architecture, you want to try and think of it in these terms as well. The third one, again, as we said, now I'm trying to build a truly intelligent application. Great, I've now enabled trend analysis, but now I also want to try and do stuff like predict what the price of the ticket might be or price of the hotel room might be 4 or 5 days down the line, so my customers have a better idea as to when they should be buying a particular ticket or a particular hotel room. And so in this case, I've got data coming in from not only my website, but now I'm also pulling in all the historical data that I've been collecting from my website from my website logs, historical purchase data, not only from my website, but from other travel websites as well. Storing that data in a warm store so I can start doing some real meaningful data processing on top of it. Now we're really talking big data here, because now we're not only pulling from our data store, we're also pulling from other data stores. So in this case, we need a big data processing tool that's going to run on a schedule, that's going to process my data, churn through my data, and start finding trends in the longer term, right? And then we can also use certain advanced analytics tools, right? We've got a lot of advanced analytics tools available within Azure, and that's where the term artificial intelligence comes into the picture as well. We're going to use advanced analytics tool to try and make those predictions as to when what that price will be 4 or 5 days down the line, or when the price is going to be at the lowest, give people a buy or sell indicator, or buy indicator, or not buy indicator, or wait indicator, and so on and so forth. Now once I've made the prediction, I can store it in an analytical store. And the reason why I'm choosing an analytical store in this case as opposed to a hot store is because now that I'm actually doing some very, very, very meaningful insights or meaningful analytics on top of my data, I want to be able to slice and dice my data and drill down into my data in real time into my application. Now, it could be that I pull all of this, meaningful process data within my application and show some really meaningful, reports or indicators to my customers and improve their experience. Or I can even show it to my C-level executives to say how our website's doing, in real time, and also in a long-term analysis, say the past 60 days, 90 days, and so on and so forth. One distinction I would like to make is that the reason why we need batch processing as opposed to just doing everything in real-time processing is because everything that happens in real-time processing happens in memory, right? And so at some point you're running out of that component where, hey, you need to look beyond just the 1-day window or 2-day window, and you need to look at 30 days, 60 days, or even a year. And so you really need a big data processing tool that can run jobs on a schedule as opposed to just running it in real time. And again, don't forget about the boxes. We are covering the components, which is you've got an ingest phase, you've got a processing, you've got your storing or staging, and then you've got your serving component there, right? And so we're using our analytical store to serve the data, and we're using the analytical store and the data lake store or the warm store to actually keep our data or store our data for the longer term. All right. So that brings up a very important question, which is we've gone through these different solution patterns. We've understood what the different data patterns are. But the question we get every now and then is, hey, what are my technology options? Great, you've explained all of this to me, but which technologies can I use within Microsoft Azure today to try and do this? All right. So let's go through our the different types of tools that we talked about in this slide again. So the first thing we talked about was messaging queues. Now this is to try and ingest your data. This is what I called as a data catcher that just catches your data no matter how much you throw at it. And so it can then hand it off to whoever wants to process it. It does not do any processing on its own. That's a very important thing to understand. That does not do any processing on its own. We've got some very good high throughput messaging queues in our in our cloud, and some of them are Azure Event Hubs, Azure IoT Hubs, and also Apache Kafka, which is an open source high throughput messaging queue. And that's all available as managed services within Azure, which means you don't have to be in the business of managing VMs, right? But if you're not seeing like thousands of messages come in per second, you can also use some slightly less expensive queues such as Service Bus queues or Azure Storage queues. The next one is, now that we've ingested our data, it's time to process it in real time. And so what are our processing options in real time? And so we've got a few options there. We've got Stream Analytics, which is a first-class managed service within Azure that lets you write SQL queries on top of your data in real time and process your data. Now, if you're like me and you like open source, you'd want to try and stick to an open source tool. Both of them are a really great option. But for the open source lovers out there, we've got Apache Storm. Again, it's available as a managed service within HD Insight, which is our flavor or our implementation of Apache Hadoop within Azure. And then we've also got Apache Spark Streaming, which is a streaming component within Apache Spark that lets you do near real-time processing. Now that you've processed your data in real time, it's now time to understand how to bring in or store your data in a hot or a transactional store, so you can either pull it within your application or run some or just pull it into any kind of a dashboard. So in this case, our hot stores, we've got a lot of options, and again, this is not an exclusive list or an exhaustive list by any means. And this also includes the latest managed MySQL and Postgres services that we just announced today at the keynote. And so as you can see, there's tons and tons of different options available for you, including some .NET friendly services such as DocumentDB, such as Azure SQL DB, and also some databases that have traditionally been open source databases. We now support all of them. And the best part is if you're using any of the managed Microsoft services as well, including DocumentDB and Azure SQL, you can even use open source languages with them. They're kind of now becoming language agnostic and are no longer just limited to .NET. And so, now that we go through the hot store, we also want to try and store our data for, further processing. And so we also want to try and understand what our options are for cold store or for warm store, so we can archive our data or even just store it, so that we can further process it using a batch, a big data processing tool. And so our options there are Data Lake Store, which is again Azure Data Lake is a managed data lake service within Azure, and Data Lake in itself is an industry term, and we chose to use it for our service. We also have Blob Storage, which you as an app developer, as an Azure developer, or if you've ever worked with Azure, you're probably familiar with. And then you've also got HDFS within Apache Hadoop that you can use as a warm store. Though that's not the most common practice we've seen, but we have seen customers do that for reasons that that we can explain, but we don't have time. Let's talk about big data processing tools. Again, the familiar faces of Hadoop and Spark come into the picture, but we also have some tools that Microsoft has built, such as Azure Data Lake Analytics. Microsoft also has something called a SQL Data Warehouse, which is for your processing needs if your data is in SQL format, right? One of the most common questions we get is, when do I use Data Lake Analytics versus SQL Data Warehouse? And this should hopefully help you answer that, which is when you have non-relational data versus relational data, and you want to process that data, you want to try and use one over the other. The best thing about SQL Data Warehouse is if you come from the SQL world and you are running SQL Server or something along those lines, those stored procedures almost exactly translate to SQL Data Warehouse, and you don't have to do much work or much heavy lifting in order to port over those stored procedures or those triggers onto SQL Data Warehouse.
And the point there is really about the fact that you want to do processing where the data is.
Exactly.
So if your natural data gravity is relational, then you do it in data warehouse. Right?
Exactly. That's a great point, Vyong. We also have Microsoft R Server that you can use to process your data. It's a distributed server. It's what traditionally used to be called Revolution Analytics. That's now called Microsoft R Server. You can also perform advanced analytics tools, and I don't want to spend too much time into this because we are trying to do an introductory session here. But there are tons of options for you to do, advanced analytics on top of your data, predictive analytics, AI, and so on and so forth, using deep learning. And then finally, you also have analytical store the options that are available in Azure. You'll notice they're pretty similar. The analytical store options are pretty similar to hot store options, but there's a main difference. There are a couple things I would like to call out here, which is Azure Analysis Services fits into an analytical store because it really helps you slice and dice your data and drill down into your data as you call it within your application or your dashboard or reporting. And so there's slight difference, but you can see most of the databases that are OLTP stores or hot stores can also be used as analytical store, though there are some exceptions there. One thing I want to call out here before we move on is that you can see something like Hadoop and Spark are, those open source frameworks. They try to build all of these different tools within them, and we support them all. And so, you don't have to stick to any one programming language or need to learn a new programming language in order to actually run a data-driven application on our cloud. It's actually pretty language agnostic, and you can use any language of your choice to do your application. Sure. Now that we've learned a lot about it, I want to hand it over to Vi Hyong again, who's going to test our knowledge on these different data services.
So that's great, right? We talk about the different kind of solution patterns. We talk about all the technology options that's out there. So let me give you a scenario. Right? And in this scenario, it's really about the fact that, well, if you're a product manager or a program manager, and you build this really amazing application, right? And you really want to get a 360 view of the product that you have built, right? Or the application that you have developed, right? And the point there is, with data signals coming from social media, data coming from your telemetry systems, right? And data just coming in from your relational store, right? How do you go about cooking all this data, getting this data processed in a way that will eventually give you insights and allow you to serve this via dashboards and reports so as to help you make an informed decision.
Right. And which makes sense, right? Because I think when I'm looking at trend reports, I need to collect as much data as possible from as many different sources as possible.
That's right.
And I think it goes into a market.
That's right. And in fact, every time we do something like this, one of the things that we tell our product or program managers is that the secret to understanding your customer is really very simple, right? It's to listen, right? Listen to what they're using, how they're using the product, use telemetry data to gain even more insight to what kinds of API calls are failing and so on and so forth, right?
Great.
And this is really about listening to all the signals that's coming and then cooking it and delivering and serving it.
Great.
Right. And therefore, to map this into the frame that we have described earlier, right? We start off with, well, what kind of options do you have if I want to be able to do real-time ingestion and being able to do processing of this continuous stream of data, right? That maps to one of the technology options that Romit has shared, which is ingest all this data via an event hub because it allows you to ingest millions of events or messages per second. But then more importantly, being able to process this in real time using a real-time processing engine like Stream Analytics, and finally being able to push this real-time insights into Power BI and visualize it and being able to get insights into things that are happening at this point in time and being able to react to it. Right. By the same time, a lot of these insights could also be pushed to a store, right? And in this case, if you have huge amount of data and you want to store them, whether it's raw data or processed data, you want to store them over a long period of time because there could be business questions that you need to answer now, and there could be business questions that you want to answer months or years later. You want to have the confidence that this raw data is sitting somewhere and is safe. Right. And in this case, we could store this data in a data lake. Right. But more importantly is, remember we talked about the fact that we want to push compute to where the data is.
Correct.
Right?
Yep.
Now that you have huge amount of data, it could be petabytes of data sitting in the Azure data lake, right? Data coming from all the different signals. How do you do processing on it, right? And yet without having you to move the data.
Right. And so I think that's kind of the advantage that Data Lake also brings to the table, which is you've got your Data Lake store and your analytics that's co-located. Even though they're separate, they're co-located, so it's easier to process.
Exactly. And more importantly, one of the things that people ask us a lot is, well, it's not just about traditional kind of processing. What if I want to do advanced analytics or AI or being able to leverage my machine learning models on this data sitting in Data Lake? Right? Today, Data Lake support what we call cognitive capabilities, and therefore you could do key phrase extraction, you could do sentiment analysis, you could even do image tagging on the data as it is sitting in data lake. And that kind of big cognition capabilities available at your fingertip is just phenomenal.
And so it's kind of even adding both the components of processing your data and curating your data, and then also running advanced analytics all in the same place.
That's right. And sometimes when you process this data, you might want to bring in reference or master data. And more than often, a lot of this data sits in a relational data store. It could be an Azure SQL database. And therefore, today, the Data Lake provides, or Data Lake Analytics provide you with this ability to do federated queries on data that's sitting in the data lake against data that's sitting in a relational DB like Azure SQL DB. And that just allows you to have even more powerful ways to enrich your data.
Great.
Right.
So let's learn what the next steps are.
Right. And then the remaining piece is, well, now they have all these insights, right? This insights coming from your regular big data processing as well as your cognitive or smart machine learning style processing, you want to bring this data and allow your users, right, to be able to do interactive data analysis. You could leverage Azure analysis services for doing that, but more importantly, as you build your cube, as you process your cube, you can bring all these cognitive insights, if you will, from your data lake, right, using SQL Data Warehouse by using a feature called Polybase over Azure Data Lake Store. And that allows you to pull the data straight through, process your cube, and now it allows you to have that slice and dice or interactive experience in Power BI.
That's awesome. So now that we've learned so much in such a little amount of time, we want to try and give you a little bit of cheat sheet to help you with your next data application. Now, I know this is probably not going to solve all of those problems out there, but hopefully for you that are starting off, that are trying to understand which data source to use for when, this cheat sheet can act as a helping guide.
And this kind of cheat sheet is things that is also back of our mind every time we go into a customer.
Exactly. This is the kind of thinking that we go through as well when we try to architect a solution for our customers as well. And so when you have app data coming in, the first question you're going to ask is, hey, do we want to process our data in real time? If your answer is yes, we have different flows that can help you process your data in real time and then understand if you want to store that data and then what do you want to do with that data. And then if your answer is no, we also have other options to try and help you understand where that data needs to be directed so that it can be used for whatever you want to try and do. And so again, we don't want to spend too much time on this because we've already just spent too much time on explaining to you how the different services actually fit together and which service to use when. This is more of a cheat sheet so you can look at it at your own pace. These slides will be available to you so that you can look at it and understand, okay, when should I use what type of processing tools and what should my thinking be as I start to architect my own application and as I start to define my own data requirements for my application. And so similarly, just like we talked about for the real-time processing, we also have a similar kind of flowchart for our batch processing needs as well. And that includes questions about even advanced analytics. So if you're trying to do batch analytics and then also try to run an advanced analytics, it kind of hints at, okay, what type of tools should you be using? And then we've also provided the list of tools available or the list of services that help you perform a certain action. For example, in our slide right here, we're talking about using a big data processing tool or advanced analytics processing tool. You can go back to our slide and look through which options you have to process, say, big data or say to do advanced analytics as well, right? And so just to tie a ribbon at the end and close it off, I wanted to give you a few call to actions. I wanted to try and make sure we communicate with you the different things that you can go and do. You can go to our website, aka.ms.cis solutions, that helps you get up and running and get started with some sample solutions that involve data and data processing. There's also some labs that we've built for you and that you can access. So there we've put in a link for you that you can go. It's a self-paced lab. It's self-explanatory. Just go in, follow the steps, and you'll have your first application with both real-time and batch processing ready to go in no time. Finally, if you are at Build or if you are watching online, there's some sessions to watch out for that are very related to what we're talking about here. I would highly encourage you to go to these. We've got our CVP, Joseph Sirosh, who will be talking about how data and AI are merging, and that's session B8081 that's happening on Wednesday, May the 10th. That's today. And then we've also got other sessions that I would encourage you to go look at. With that, I think we've come to an end of our short and brief talk. I hope you found this useful, and we really hope that this will help you and motivate you and inspire you to go build your first data-driven application and make all of your applications smarter and intelligent.
Yeah, thank you. Thanks a lot for tuning into the session.